Hi everyone, I wanted to do a quick video about the mole concept, and it sounds very crazy and very extravagant and really scary sometimes to students, but I wanted to explain it to you in terms of unit conversion factors, like what we've been doing when we just convert units in the terms of dimensional analysis, okay? So I wanted to give you a little roadmap. In chemistry, 1 mole, okay, is 6.022 times 10 to the 23rd of anything. It's just like a dozen or a pair. It's another word for just a number of something, okay? But in chemistry, it's very helpful for us to use this mole, okay, to specify how much of something we're going to have. Atoms are very, very tiny, so we have a lot of them to be able to get them to a macroscopic level, a level that we can see, okay? So I've got some practice problems for us to look at, but as we go through and we talk about mole concepts, okay, we need to remember that if we're converting from atoms, molecules, particles, even peanut butter and jellies of something into grams, we have to go through moles, okay? So let's do our first practice problem and ask ourselves, how many atoms are in 34 grams of potassium? Now, with this, we can make some new unit equations. Remember, we talked about how we make unit equations into conversion factors, okay? So let me get my periodic table. Usually have it closer on the ready. Okay. So we're going to use our periodic table and some other things. Okay, now some unit equations that we can know. 1 mole of anything, okay, but specifically potassium, is 6.022 times 10 to the 23rd particles, or atoms, or molecules, or peanut butter and jellies. It doesn't matter. 1 mole of anything is 6.022 times 10 to the 23rd, in this case, atoms, okay, of potassium. So that's one unit equation, one new unit equation that we can use. And then the other thing we need to know is that 1 mole of potassium is how much that it weighs. And we get that from the periodic table. So I'm going to show you my periodic table. It's got a big glare on it, okay? But we look at the bottom of the box on the periodic table, okay? And there's potassium. It's K. It's weird. But one mole of potassium is going to weigh 39.0983 grams, okay? So these are the only 2 new unit equations that we need to use, and we're going to use them exactly like we used our unit equations before, okay? So let me write this down, 39.0983 grams. Okay, so here are our 2 new unit equations. Now, just in chemistry, like we said before, we're going to start with what we know, and we know that we have 34 grams of potassium. So we're going to write 34 grams of potassium. We're going to set up our unit conversion factors from these unit equations, okay? So this isn't dependent upon whatever we're dealing with, okay? So this unit equation here, if we have a mole of paper clips, 1 mole of paper clips is going to be 6.022 times 10 to the 23rd paper clips. This isn't dependent upon what the identity of the substance is, okay? This is dependent upon what the identity of the substance is. So 1 mole of potassium is going to weigh 39.0983 grams. We get that from our periodic table, but 1 mole of paper clips is going to weigh a lot more of this because each individual paper clip weighs a whole lot more, okay? So this one does depend on what we're dealing with. Okay, so we have grams on the bottom, and just like any good conversion factor, we want to put grams on the top. So we have our unit equation here, 39.0983 grams is in 1 mole. Now notice with both of these unit equations, the 1 goes with the mole, okay? That can help you remember to not get it mixed up. Okay, so that cancels out our grams. okay? And then we need to set up one more unit conversion factor where we put moles on the bottom. Okay, and that's going to be 6.022 times 10 to the 23rd. Okay? And that's atoms. And I didn't leave myself enough room. Okay? And that's what we need to end with. So our moles cancel out. Plug this in my calculator. Okay. People are talking outside my office. So then I end up with, I only do the big numbers and then I carry the exponents off, okay? So this gives me 5.2, because I only have two significant figures here, times 10 to the 23rd atoms. Okay? Now, that is going all the way from here to here. I'm going to have to use two unit conversions. I don't always have to go all the way from grams to particles, okay? Sometimes I'm going to go here and go here, or go here and go here, okay? So this is Avogadro's number. Sorry, they're being really loud outside the door. Okay, so this is my first, this is here, and then this is here, this is here. Okay, so how many grams does 1 mole of water weigh? So I know I have 1 mole of water, I just need to convert it to grams. So I'm going to use my molar mass, okay? So I have 1 mole. Let's see, I don't want to use water. I'm changing my mind here. I want to use copper. Okay. I'm going to change this a little bit because we haven't gotten to formula mass yet. Okay, so for my periodic table, I need to formulate this unit conversion factor, okay? Or this unit equation. 1 mole Cu is equal to 63.546 grams. Okay. So because this is 1, it makes it very easy. 63.546 grams. Okay, and that's how we use the mole concept. If you have any other questions, message me and let me know.